A psychologist is studying the senses of taste and smell by administering 20 different foods by dropping a liquid on the tongues of students. Based on her past research, the mean number of the 20 foods that students can identify correctly is 13, with a standard deviation of 3. And the distribution of scores follows a normal curve. The psychologist wants to test whether people do worse on the task when they are only able to taste the liquid compared to when they can both taste and smell it. Note that this is a directional hypothesis. The psychologist then tries the procedure on one randomly selected student when smell is not a factor. This student is able to identify only 8 correctly. Complete parts A through B. Okay, so let's think about this. Using the 0.05 level of significance, what should the psychologist conclude? First, determine the null hypothesis. So recall, the null hypothesis will often use the symbol HO, is often called the dull hypothesis, no change. So in this case, we're talking about means. We'll often use the symbol mu for that. So I like writing things symbolically. So that the mean, looking at the mean, and then the alternative, we'll often use HA or H1. I can't remember what this book uses. Again, we're talking about the mean. So the alternative hypothesis is also called the research hypothesis. And so right here it says the psychologist wants to test whether people do worse on the task. So she's expecting, without that other sense engaged, that they're going to do less than the mean of 13. They're going to do worse. So the null is the exact opposite of the alternative. It will always contain the equal sign. So often we just say equals 13. And here though, we'll just go ahead and say greater than or equal to 13, which is the opposite. And then you can relate this back into words so that they will do the same, which is equal, or better on the task, is the null. So that would be A. If it has the alternative, it would be that they would do worse. And that's actually what this next little part asks. Determine the research hypothesis, which is this H1 that we've already mentioned. And it's that they do less than the 13. They do worse than that group. And so that is, again, A. Okay, so this part A has a lot of subparts, doesn't it? So it says determine the comparison distribution. So it reads up here that it is it does follow the normal curve. So this is going to be a normal comparison distribution. So now it wants to know the sample cutoff scores. I will often draw this out, normal curve out, and label it. I don't think we need all of this, but I still like to put it in there. So our mean was 13. Standard deviation was 3, I believe. And we're wanting this value right here, right? So our cut score, right, is separated by these two pieces. So let's turn to the applet in StatCrunch. So we're going to go to Stat, Calculators, and go down to Normal. Leave mean 0, standard deviation of 1. So for this one, we're going to leave the mean and median. When they say cut scores, they mean on the standard normal curve. You would think they would mean on the curve that we're going to be using, but they're not going there. Just wanting to know the cut scores. So we have the mean of 0, standard deviation of 1. And we're going to and change this to 0.05. Remember it said at the 0.05 level of significance. Now this was a one-tailed test, right? So that's why we didn't do 0.05 divided by 2. If it had been a two-tailed test, you do 0.05 divided by 2. You get a different cut score. Ours is a one-tailed test. So we're at negative 1.64. Now determine the sample. This is a long part A, isn't it? This is it says determine the sample's score on the comparison distribution. Okay, so we're looking for that value. We're going to use the z-score, so z equals x minus mu over the standard deviation. If you recall from the problem, it was 8 was our x value. Let's see if I can scroll up there. Right here. So identified 8 correctly. So we want to know how extreme that is. So we're going to say our z value is 8 minus the mean, which is 13, all over the standard deviation, which is 3. So now what do? Decide whether to reject the null hypothesis. Choose the correct answer below. So let's go back and look at our curve. So here's our curve. We are in this region that we're calling this yellow region here to the left of negative 1.64. If it hits that region, that means it was rare enough that we would reject the null hypothesis. So it is in that region, so we are going to reject the null hypothesis. And we only have two choices here, reject. So reject the null hypothesis because the sample score is more extreme. Yes, it is more extreme. It's more to the left in this case, is that extreme. Okay, illustrate your answer with a sketch showing the comparison distribution, the cutoff or cutoffs, and the score. So this is a normal distribution, so we're looking at B. And then what values do we have here? They are a little exaggerated. They're not to scale. So we have negative 1.67 and negative 1.64. Okay, explain your answer to someone who has never had a course in statistics, but who's familiar with the mean, standard deviation, and z-scores. So, since the sample score was less extreme, no, we said it was more extreme, right? We said that up here. Since the sample score is more extreme, this is looking good. The cut scores, that means probably that score occurring, given that the null hypothesis is true, is less than 0.05. Yes. So on this one, it's really developing a lot of the theoretical work that's behind the scenes. We're not going to do a whole lot of these. We're going to use the computer to really crunch these out, and we can get at the exact what's called a p-value with StatCrunch. But it's good to see a couple of these and to work out a couple of these on what's happening behind the scenes. So I know that's a long problem, a lot of work, but hopefully this will help.